Okay, in this video I'm going to give you a rundown of several options pertaining to variable selection procedures in SPSS, and more specifically we're going to be focusing on the context of binary logistic regression. The data set that we have right here is actually downloaded from this textbook website. Basically, Tabachnik and Fidel, they have a chapter on logistic regression, and so they utilize some of this data to demonstrate that. So what we're going to be using in our demonstration is this variable right here, children. And so basically we have individuals who responded to various questions and survey measures. And so children is a dichotomous variable. It's dummy coded, where a 1 indicates that the person has said that they have children. A value of 0 indicates not having children. We also have some variables: locus of control, attitudes towards current marital status, attitudes towards the role of women, socioeconomic status, and attitudes towards housework. So we're going to be using some of these variables right here as predictors of whether or not a person indicates having children. So, but before we get started, there are a couple of things to keep in mind or understand when it comes to variable selection procedures. The first concept that you need to be aware of is the notion of nested models. And what that basically pertains to in the case of regression, and in our case of binary logistic regression, is that we can have various models that contain different numbers of predictors with common variables. And so essentially you can have, for instance, you can have a very general model such as this, where we have 4 predictors, where we have variable 1, variable 2, variable 3, and variable 4. And then we could also have another model where we would have just variable 1 and, let's say, variable 3, and we are accounting for variation, some outcome. We could even have another model where we would just have variable 1 as a predictor of some outcome variable. So the deal is that this model right here, we'll just call this model 1. This is the most general model, whereas we have model 2 and model 3 right here, and you can see that models 2 and 3 are nested within model 1 because we have the same predictor variables of variable 1 and variable 3 that we have in the more general model up here. And then down here we have variable 1, which is nested under this model as well. We also have variable 1 nested within this model, model 2, containing the 2 predictors. So basically, when it comes to the concept of nested models, we can see that we can have some models that are nested within other models. And this is important because when it comes to the issue of variable selection procedures, there are various strategies for working with nested models in order to accomplish various types of research aims. So I'm going to show you a few selection procedures and walk you through this concept, but you do need to understand this concept of nested models in order to understand kind of what's going on. So in this demonstration right here, let's say that we'll start off with entering all of our predictors at the same time. So we're going to be predicting the children variable, basically presence or absence, as a function of locus of control, which is this variable right here, attitudes towards marriage, which is this variable right here, attitudes towards the role of women, so I'll just call this AR right here, and we've got socioeconomic level and attitudes towards housework, so SEL and housework right here. So one strategy is just when it comes to running our regression is to enter all of these variables simultaneously. And so this is probably the most used approach to entering variables, just basically treating them all as simultaneous predictors of the outcome variable. In this case is the presence or absence of children. However, we could also run a model where we have just locus of control as a predictor of attitudes towards children, or presence of children, or we could have a model where we have locus of control and attitudes towards housework as predictors as well. So these are, so these are different kinds of models that we could have. We could see that, both of this model right here and this model right here are nested within this model. You could also see that this model right here is actually nested within this model here. So again, we have to think in terms of nesting or nested models. So I'm going to start off by running what amounts to be, actually there are a couple of general strategies that we could take. We could take either kind of an empirical strategy where we essentially allow the computer or the algorithm for the program, empirical, to identify the best set of predictors by either adding predictors to models in a sequential fashion or removing variables in a sequential fashion. And so allowing the computer to basically pick predictors that sort of increase model fit or to remove variables in a way that results in the least amount of decrease in fit. So let's start off with, that's the empirical strategy. The other approach is really more of a hierarchical strategy where the researcher has a lot more control over which predictors are added at each step. So we're going to start off with the empirical strategy first, or a couple of empirical strategies. We're going to go to Analyze, Regression, and go to Binary Logistic. So in this particular case, I'm going to move presence of children over to the dependent box, and I'm going to go ahead and add in all of the predictors for my model into this box right here. And so you can see right now the method, it says enter. So this is essentially entering all the predictors simultaneously if I stick with this. So just to demonstrate, if I click on OK and run, you can see first of all, block 0 is essentially a model that only incorporates the intercept. So there are no predictors in this model, and so it's not terribly informative in and of itself. But this is essentially serving as a baseline of comparison against other models, because essentially, if I have a model, we could think about the intercept only model as just essentially a model where we have all our predictors in the model, but then if we think about the paths themselves, they are all fixed at 0. So all the path coefficients are fixed at 0, meaning then that the only parameter being estimated in the model, that'll be 0 and this will be 0, the only parameter being estimated in the model is actually the intercept. So this is, and so when we move to block 1, this is a model that would incorporate all of the predictors. So you can see right here we have the model likelihood ratio chi-square test, and this is essentially comparing our model that contains all of our predictors, and so these are the variables in the equation. These are all of our predictors with their respective regression weights and significance levels. And so essentially this involves a comparison of our model that incorporates all of our predictors versus a null model that essentially is no predictors. Or another way of putting it is that all of the regression coefficients would be equal to 0. So what we have right here is a statistically significant model, and meaning that our model with all our predictors represents a significant improvement in fit over a null model. So you can pretty much gather that our null model is nested within our full model right here. Okay, so let's go a little bit further, and I'm going to go back here. And under options, by the way, a couple of things I tend to ask for is Hosmer-Loomis show and the confidence interval for the odds ratio, just to kind of show you what that looks like. There's the Hosmer-Loomis show test, and now we have our confidence interval down here. Just as a recap, though, when it comes to the likelihood ratio chi-square test right here, if this is significant, that means that we have a significant improvement in fit over the null model, which is essentially indicating an indicator of good fit. The Hosmer-Levy-Show test, non-significance is generally taken as an indicator of good fit. So just kind of keep that difference in mind when it comes to interpreting fit. Okay, we also have the model summary table. We've got the pseudo R-squares. I'm not really going to go into going too far into interpreting all these things since I kind of cover these in other videos, but just to kind of highlight, you know, what you're looking at. And then down here, in terms, we have the classification table, and then the again the regression coefficients, significance levels, and then this column right here contains our odds ratios. So let's now try a different approach. We've just done, we've entered all our predictors simultaneously. Now let's try an empirical strategy. In this case, we're going to try a forward approach. So we're going to essentially start off, what will happen is the program will select the best predictor of the likelihood of a person indicating having children. Then, in a successive step, it will add in the next predictor that will contribute to that likelihood, and so forth, up until a point at which there's no additional variables that can be added in that would contribute significantly to the model. So we're going to click on OK and take a look at it. So as we're looking at this, you know, again, looking at our output, it always is going to start off with block 0. So that's a beginning block. That's the intercept only model. When we scroll down and we look at block 1, now you see it says forward stepwise likelihood ratio. And so essentially this first step right here, the program has selected the best predictor of the model. So essentially that predictor, if we scroll down and look at our variables in an equation, you can see that the attitudes towards the role of women was the strongest predictor. So essentially started off by choosing that variable. You can see it's statistically significant. So this is essentially model 1, and step 1 was basically involved selecting this this variable right here as the strongest predictor. And so when we scroll up and we look at our results, you know, this step 1 is again, it has that first predictor in the model. So, and you'll see that all the chi-square values are all the same. All this information is the same at step 1. This is essentially our model 1. You could think about the null model as essentially being model 0. So at any rate, then you have step 2. And for step 2, it adds in the next strongest predictor. And so you can see right here that we have a likelihood ratio chi-square value. And this is a comparison of the second model. This would be model 2 in relation to the null model. So this is kind of generally capturing overall fit of our model with 2 predictors relative to the null model. And the step is this right here, the significance test, is testing the improvement in fit relative to model 1. So in other words, this being significant means that when we added in the next predictor, then we had a significant improvement in fit for model 2 relative to model 1. So if we want to see the second predictor that was included in the model, we can go down here and say that we have step 2. And so now previous model had attitudes towards the role of women. We still have that, but now we're adding in attitudes towards housework. And so this was also a significant predictor in the model. Then just before I scroll up, we have this is essentially going to be model 3. So this is model 3. This is model 2. And this is model 1 right here. And again, the null model just contains no predictors. And so essentially in this particular model, we added, in this one, we have still attitudes towards women, housework, and then it adds in marital status, attitudes towards marital status. So you can see all of our predictors were significant in the model. There's our significance levels. And but you'll notice that we don't go any further. We had more predictors. You'll notice down here it's you know, variables that are not in the equation. So even in model 3, we don't have locus of control and socioeconomic level, and that's because if we tried to add those in, we would not have a significant improvement in model fit by doing so. So those are left out. And so we end up with the final model being model 3 with these 3 predictors right here. If we scroll back up and look at our test results, you'll see at step 3 you've got the likelihood ratio chi-square. So the model for each of these is just comparing a given model with the predictors relative to the null model. So so you can see that our model with the 3 predictors is significantly better fit than the null model. But then our step right here is essentially comparing model 3 versus model 2. And so by virtue of adding in the attitudes towards marital status in that third step, we essentially have a significant improvement in fit. So that's essentially how you can look at this using a forward stepwise regression. Now let's try backward. So with backward, what we're going to start off with is the full complement of predictors, and then we're going to be removing variables that are the weakest contributors in the model. So we're going to start off essentially in a series of steps. We'll start off with a basic model that contains all of our predictors. And so I'll go down here and you'll see it. So we have all of the predictors, and this is the same model that we had earlier when we entered all of our predictors simultaneously. So we start off with all of our predictors, so this is essentially model 1. Model 2 is essentially removing the weakest contributor, and that actually happens to be the locus of control variable right here, and you can see it's not significant in this model. So model 2, you see that locus of control is removed. Then in model 3, you'll notice that in this case, socioeconomic level, which is not really contributing in model 2, it's removed, leaving just these 3 variables here. So we actually ended up with the same 3 variables that we had when we were running the forward approach. So if we go back up and we look at our models, you can see, first of all, block 0 is still the intercept only model. So there's our intercept and no predictors, or you could also think about it as all the path coefficients would be fixed at 0. Then when we look at block 1, you'll see that here's our model chi-square. And so this is the exact same thing as when we entered all of our predictors simultaneously. So that's the same chi-square that we started off with. Then at step 2, that's where we ended up removing locus of control because that was the weakest predictor. So we have the likelihood ratio chi-square comparing the model without locus of control against the null model. So you can see that that's still statistically significant. And you can see right here the chi-square value, it's a negative, and that reflects sort of a drop in fit. But the question is it a significant drop? And you can see right here that the p-value is greater than 0.05. So we would say that by removing the locus of control variable, we do not have a significant decrease in fit when we do that. When we look at step 3 right here, this is essentially our model 3, where we removed the socioeconomic level. The fit of the model relative to the null was still statistically significant. So by virtue of having the remaining 3 predictors in it, it's a significant improvement in fit relative to the null. When we look at the step, it's a negative. Again, we have a little bit of a decrease in the chi-square value, but that decrease would not be deemed statistically significant. So essentially, through the backward stepwise procedure, you can see that we ended up with the same 3 predictors, it turns out, as what would happen with what happened with the forward regression. It doesn't always work out that way, but in this case, it kind of did. So those are empirically based approaches. Now, let's say I wanted to enter predictors in a hierarchical fashion. So I can do that as well. I'll go to regression, binary logistic, and I'm going to go under method here, and I'm going to select enter. And I'm going to go ahead and remove the predictors, and we'll just do this in a couple of steps. So the first thing, notice that we have block 1 of 1. And so what I'm going to do is I'm going to enter the first block of variables at this step. So I'm going to enter, let's say I want to enter in locus of control and attitudes towards the current marital status. So now you'll see that this box highlights where it says next, and so I'm going to click on that, and now I can add in another set of predictors. So let's say I want to add in the role of women and socioeconomic level. I can do that. So you can see the box highlights again where I could theoretically add more predictors in it. So let's just do that. We'll add in attitudes towards housework. All right, so now I'm going to have 3 separate models, and essentially we're going to be adding in predictors across those 3. So the blocks are just reflecting the variables that are being entered at each step. But we'll essentially be comparing a model 1, model 2, model 3, those models being, reflecting sort of a nesting structure. So I'll click on OK, and so now looking at our output, you'll see again we have our null model with our intercept only. Block 1, enter. And so in this particular case, I'll just kind of scroll down here for a second, and we'll see that we've entered in locus of control and attitudes towards current marital status. So right here, it actually turns out that neither of those predictors was statistically significant. And that can happen. We didn't start off, we didn't use an empirical strategy. We probably, for me to go through this process, if this was an area that I was studying, I would have spent some time deliberating about why I would be entering in variables at different steps. So that typically involves certain practical considerations or theoretical considerations. So at any rate, we're going to go back up here and we'll see that we have our model chi-square, the likelihood ratio chi-square test, and you can see that by virtue of adding those 2 predictors, we do not have a significant improvement in fit over the null model. When we scroll down, you'll see block 2. Well, with block 2, we incorporated, these 2 variables were from model 1. These 2 variables are being added. So we're adding these. So we now have 4 predictors in the current model as opposed to the previous 2, which was just these 2 right here. And so now you can see that locus of control and attitudes towards current marital status were not significant. Neither was socioeconomic level, but attitudes towards the role of women was a significant predictor in the model. If we want to scroll up and take a look, you can see that we have the likelihood ratio chi-square test, so it's statistically significant. So the model with the 4 predictors included represented a significant improvement in fit over the null model. Now, when we look at the step right here, and essentially that's also going to be mirrored in the block, you can see that we have a significant improvement in fit relative to the previous model that incorporated only the 2 predictors. So this test right here is comparing essentially our previous model 1 versus model 2, whereas again, our likelihood ratio test is comparing, in this case it would be model 2 versus model 0, which is our null model. So at any rate, we'll scroll down and we'll take a look at where it says block 3, enter. So in this particular case, what we've done is we've basically entered in our remaining predictors in the model. So you can see that we've got locus of control, attitudes towards current marital status, attitudes towards the role of women, socioeconomic level, attitudes towards housework. And so you can see this is the resulting model, and and obviously this is kind of the same model that we started off with when we entered all our predictors simultaneously. So hence the chi-square, the likelihood ratio chi-square test, the results are exactly the same as what we started off with before, but the change in chi-square, the increment in fit, we would say of this model, which would be model 3 relative to model 2, that increment in fit was statistically significant. So by adding in the remaining predictors, it yielded a significant improvement in fit. So that pretty well does it for talking about these various models. Like I said, these procedures, kind of the empirical strategy versus the hierarchical, these are generally nested under are subsumed under a broader topic, which is called variable selection procedures. And so you have the option of either adopting sort of an empirical strategy where the algorithm and the program goes through and selects either selects predictors to include or exclude based on whether you choose a forward or backward selection procedure. And then the hierarchical strategy is really more up to the researcher to decide which variables are entered in successive steps. So let's see if there's anything else I wanted to mention. You'll notice that under options, if you're using some type of stepping procedure, these are some of the general thresholds for either entering predictors or removing predictors. So just kind of keep that in mind. If you can theoretically reset these if you want. These are just sort of the defaults in SPSS. So that pretty well concludes this discussion, and I hope you find this useful.